All right. This is from Unit 4, Lesson 8, Solving Systems of Linear Equations Algebraically Using Elimination. Our first day using elimination. Okay, so we start off with a little warm-up with some heart and diamond emojis. So if you want to figure out the value of these, you would probably just play around with them in your head. So some of you might think like, oh, 6 plus 6 is 12. Like that's the first one that jumps to my head. But 6, if the heart is 6 and then this is also 6, 6 minus 6 is not 4. What if you thought maybe, oh, well, 10 plus 2 is 12, but is 10 minus 2 4? No, but if you play around with it enough, you'll come up to realize that 8 plus 4 is 12, and 8 minus 4 is 4. So our heart must be 8, and our diamond must be 4. So if you play around with all the different numbers, that's the solution that ends up working. Now, what if we were to look at this as an algebra problem? So we have x plus y equals 12. And then if our heart is represented as an x, we have x again, x minus y equals 4, because our y is our diamonds. Right? So we got our heart and our diamonds. We're just changing them. Instead of heart and diamond, we're using x and y. So I'm going to show you now a strategy that we can use today to figure this out without just guessing and checking like I kind of did in the warm-up. So what this is called is the elimination strategy. And I'm just going to go ahead and jump right down to the steps now, actually. So you're going to find the variable with opposite coefficients, like y and negative y, 5x and negative 5x, negative 2y and 2y. These are kind of like zero pairs, things that are going to cancel out, terms that are going to cancel out. And you're going to end up adding the two equations together to eliminate the variable with opposite coefficients. So you're going to add those two equations together and something will cancel out. Then you solve for the new then you solve the one new equation you get for the variable. And then just like we've been doing, you substitute that answer back into the original and you end up with an x comma y solution. So I'm going to rewrite these. So we have x plus y equals 12, and then we have x minus y equals 4. So if we add these two equations together, this is 1x, 1y, and then negative 1y. 1x plus 1x is going to give you 2x, but this 1y minus 1y, that's going to cancel out and leave you with no y's. And then 12 plus 4 is 16. So then we can just solve this one-step equation. Divide by 2 on both sides, and we'll solve to figure out that x is 8. Now that we know x is 8, we can go back to one of the originals. So I'm going to pick the first original because it's adding, and I like that better than subtracting. And I'm going to plug in x is 8. And then solve for y. Minus 8 on both sides. (12 minus 8 is 4, so we end up with our answer of y being 4. So sure enough, our solution is 8, 4. And remember, we had figured out that our heart was 8 and our diamond was 4, so it makes sense. So again, elimination, we're adding the two equations together, and we're looking for a term that's going to end up eliminating or crossing out. Okay, so let's try some bigger algebra examples now. So again, you're going to look for that pair of terms that's going to cross out or eliminate. So in this first one, I see that my y's are going to end up eliminating. 4y and minus 4y, when I add those together, that's going to make 0. All right, so I'm just going to rewrite my equations. When I add these together, my y's will cancel out. 3x plus 5x is 8x. 10 plus 6 is 16. We end up with x is 2. Now we have to go back and find y. Rewrite one of the originals. Plug in that 2 for x. and then we'll solve for y. 3 times 2 is 6, minus 6 on both sides. Four y equals 4, divide by 4 on both sides, and you end up with y equals 1. Our solution is x comma y, so our solution is 2 comma 1. All right, for number 2, again, look for pairs that are going to cross out. So here we have negative 7x minus 3y equals 80. 2x plus 3y equals negative 25. So when I add these two equations together, my y's are going to cancel out. A negative 3y plus 3y is 0 y's. Negative 7x plus 2x is going to give me negative 5x. 80 minus 25 is going to give me 55. Divide both sides by negative 5. X equals negative 11. Now we have to go back and find y. So I'm going to rewrite one of my equations. So now we're finding y. So this is kind of step 2. This is step 1. This was step 1. This was step 2, where we are finding y. All right, so I'm going to rewrite my second equation because, again, I just try to stay away from negatives personally, even though there's a negative 25 there. Doesn't matter which one you use. Take your x is negative 11, plug that in. And then you'll solve for y. So negative 22 plus 3y equals negative 25. You will add 22 on both sides. You end up with 3y equals negative 3. Divide by 3 on both sides. Y equals negative 1. We have our x, we have our y. Our solution is negative 11, comma, negative 1. Okay, and just remember you can check those by taking that point and plugging in negative 11 for x, negative 1 for y, and seeing if they balance. Maybe I'll check the last one for us. Okay, let's look at numbers 3. So again, let's look for our first step. We're going to look for a pair that will cancel when we add the equations together. All right, so when we add these equations together, our x's are going to cancel this time. So this time we're finding y first. 3y minus 7y is negative 4y. Negative 6 plus 14 is going to give us 8. Divide both sides by negative 4. And we get that y is negative 2. Now we have to find x. So our second step here is to find x. Rewrite one of the originals. Pick whichever one looks easier to you. Fill in negative 2 for y and solve for x. Again, this one is in a different order because it just so happened that x is canceled out, so we found y first. And now we're finding x. 3 times negative 2 is negative 6. Add 6 on both sides. Be careful over here. You're going to end up with 4x equals 0, but that's okay. We want to write a 0 because you don't want to leave nothing on one of the sides. Divide by 4. 0 divided by 4 is 0. So our solution is 0 comma negative 2. Remember, the x always goes first in your solution. All right, let's look at number 4. I'm going to rewrite them. And the first step is to add them together and solve for whatever variable is left after you eliminate. So when I add these two equations together, my x's cancel out. So I'm going to be solving for y. 6y plus 2y is 8y. 21 minus 5 is 17. Was it 16? 16. Divide both sides by 8. We found that y is 2. So now our second step this time is to solve for x. Let's rewrite one of the originals. I'm going to pick the second one since there's no negative at the beginning. And let's plug in what we got for y. So we're going to plug in our 2 for y and see what we get. 5x plus 4 equals negative 5, minus 4 on both sides. You end up with, what did I do wrong? Y is 2. 2 times 2 is 4. Negative 9. This one's not working out neatly. Let's see. 21 minus 5. 16 divided by 8 is 2. 2 times 2 is 4. Let's see. This one is not working out neatly. Let's see what we get. We end up with negative 1.8. Let's see if we plugged it into the other one. If I plugged in 2 for this, we would get 12. 21 minus 12 is 9. Yeah, all right. So we're getting a decimal here. So x is negative 1.8. And now let's take that and write our solution. Negative 1.8 comma 2. All right, we've got 2 more. For this one, when we add our equations together, our x's are going to cancel out, and then we're going to be left with 6y equals 30. Divide both sides by 6, and we get y equals 5. Now let's go back and find x. So I'm going to rewrite one of the originals. I'm going to plug in my 5 for y. Negative 2 times 5 is negative 10. I'm going to add 10 on both sides. 4x equals 32. Divide both sides by 4. Now I'm questioning all my math skills. And we get x is 8, so our solution here would be 8 comma 5. Oops, sorry. And now let's do number 6. We'll also check this one. Our x's are going to cancel out when you add the equations together. Oh boy, and our y's are also going to cancel out. Negative 3y plus 3y is 0. So for this one, when we add the equations together, we get 0 equals 16. That's not a true statement. So for this one, this would be an example where there's no solution. Okay, since that one's a little bit more difficult to check, I'm going to go back to number 5 and show you the check for that one. So for the check, you would rewrite both originals. I'll just do it down here. And you're going to plug in 8 for x and 5 for y, because that's what we found. 8 for x, 5 for y, and see if they check. So 4 times 8 is 32, minus 2 times 5, so 10, or negative 10, see that? 32 minus 10 is 22, so 22 equals 22. That means that the 0.85 is on that line. Let's see if the 0.85 is on this line. This is going to give you negative 32 plus 40 equals 8. And sure enough, 8 equals 8. So that point is on that line, so it checks out. So that's a great way to check it, especially if it's multiple choice. Just take the solutions, plug them into both equations, and see which one balances out. So I just want to point out, we did the elimination strategy today because these equations were set up neatly for elimination. We had pairs of terms that were going to cancel out. So the substitution strategy, sometimes it'll make sense to use that when you have like y equals something or x equals something. When you have two equations like this where you see pairs of terms that are going to cancel out, you want to use the elimination strategy. And then there's the graphing strategy as well when they're in y equals mx plus b form. So 3 different strategies, all for solving systems. This was the elimination strategy today. All right, thanks.